Now the potential for a dipole. Dipole potential, to measure the potential for a dipole. So this is a dipole of plus q and minus q, and the distance between them is 2r, sorry 2l. As we read in the electric field chapter, if we want to calculate a electric field of for a dipole at a particular point, we must take the distance from the dipole of that point from the center of the dipole. So this position is very important, from where we are taking the distance. So, and also we have read that there are two extreme positions for the dipole, for the electric field for the dipole, and those positions are one in the radial position, axial position, and another in the equatorial position. And also we must remember that to calculate the electric field we always consider the direction, and for this there was the pretty simple step, because both this electric field vector for that one and for that one along in the same line, so we just deducted both of them and calculate the electric field. But for the equatorial position they are a bit different. Here we just use the vector components and distributed them along different directions, and ultimately we calculated them in a particular direction. But as the electric potential is a scalar quantity, we need not to calculate in that way, and it is pretty simple. How? First of all, for that point, for this axial position, we just need to calculate the potential for that charge and the potential for that charge, and then just we have to look which one is greater, and the resultant electric potential will be greater 1 minus the lesser one, like this. For that charge the potential will be here, if it is 1, it is 2, V1 will be Q by 4 pi epsilon, or epsilon 0, whatever, take the medium. So this is 12, and the distance from the middle point to that point is r. So actually the distance between this charge and the point is r minus l, and the distance between this charge and the point is r plus l. So V1 will be Q by 4 pi epsilon r, and what is the r? Here is the r, l minus r minus l, and V2 will be Q by 4 pi epsilon. What is the r? R is that means r plus l. Now, as we know, the denominator, it has the greater value, so V2 will be less than V1. So the resultant potential will be V is equal to, which one is greater? Now V1 is greater and V2 is less. So V1 minus V2, and the Q by 4 pi epsilon, just take the outside, and 1 by 4 pi 1 by r minus l and 1 by r plus l. Just calculate 4 pi epsilon and r plus l minus r minus l, this will be the plus, so that plus r and minus r gone, 2l. So q into 2l by 4 pi epsilon, and now just put here the dipole moment P is equal to one of the charge multiplied by the distance between the two dipole poles. So this is q into 12, and here just put here P into 4 pi m. Now just put this point as A. That will be better to understand, because that P and that P will be mixed. So this is the electric potential for a dipole at an axial position, and it is pretty easily calculated. Now the potential for the equatorial position, and for that, like the electric field, we just add these 2 points and take the distance. We need the distance here, because in case of calculation of potential, the distance is the key, because there will be no direction attachment here. So only what is the basic formula of potential, Q by 4 pi epsilon r. So we need Q and we need R. If there is Q, we just need to calculate the R. And now in this case, what is R? This is the R and this is the R. So this is, I'm putting this is R, this is R. Now this is, sorry, that not R, this is the R. So what is, this is L, this is L. So this is R, so R square plus L square root over, and this will be the same, R square plus L square root over, and the rest is like this. So this is a task for you to calculate the electric potential for a dipole at an equatorial bisector position, and just show you the axial position calculation, and just you can do it. This is the task for you.